Okay, perfect. Everything is set up. So now the question is, what are the topics?
I think we have a few.
Okay.
So, well, personally, I want to make two simplification suggestions in C system matrix.
Yeah.
And I also, I kind of asked Stefan to be here to explain is like chaotic derivative problem, because we are having this problems with time domain, but both for the primal with symmetry and Euler boundaries. So we have that issue that is, the one with the Onera case.
What exactly are you talking about?
So there's a few time domain problems with the code at the moment, it seems. One with the primal code that there's this the difference between 6.01 and 6.2 that currently the code is not able to reproduce some results from with some unsteady results with Euler boundaries and so on. And there's a few like questions on CFD online of people that I think are running into these problems.
Okay.
So I don't know. I get the feeling that we should try and do something about these time domain problems. And Stefan found a similar thing, a similar difference in behavior in the code, but for the derivatives instead. So.
Yeah, not only for the derivatives, it is for the simulation, the primal simulation as well. And, Tim, it is this problem we talked about that I discovered in somewhere in December, where with this NACA airfoil test case, and there, the primal output shows a bit of a changed periodic behavior, so to say, from an older version. And then somewhere in December, there was a commit that changed somehow this flow behavior. And while this does not seem as that much of a problem, the derivative then in a newer version is kind of chaotic, so to say, when the older one was periodic.
I can remember, but I think this is probably due to some changes in the numerics, right? I mean, I think that Tom just joined.
Yep. Hey guys.
So yeah, Tom, we are just talking about I don't know whether you read the issue that Stefan opened like a couple of weeks ago. That there is like a different behavior with the new version compared to the older version. I think, was it before 7? I cannot remember.
It was shortly before the release of 7. So
yeah, let me go back.
Yeah, maybe someone can open maybe the issue or something like that. Maybe someone can share the screen. Because there were some changes in the numerics, right? And Tom, I think that some of them were from you.
You mean the CFL?
Yeah, for example, exactly. Yeah.
Yeah.
I don't think it changes anything for time domain, does it?
Well, yeah, of course. It also changes the behavior in each inner iteration. So
it can be used for the dual time stepping as well. So if you're using dual time stepping, it would be active. Let's see.
So I don't think that this is a problem with just the time domain. This is what I think.
So I think the post here talks about the sensitivities being different. Do you have a comparison of also the primal stuff? So yeah, you have drag and.
Yeah, I think so. I posted this issue, and I can briefly show you what I mean. I can share my screen and
yeah, of course.
show you.
Sure, that'd be great.
Okay. So okay, you can see this. Yeah. So the black line, just to see. Yeah, you can see here 2 lines. The green one is from the old. So this is the drag over iteration. And the green line is from the old, so to say, the old version of the code. And after this update, you can see this, that there is a small difference in the period length also of this time-dependent case. And this results, so the settings and everything are completely the same. And now if we look at the derivative, the sensitivity with respect to one design variable of an FFD box, then we have this behavior for the working test case. And for the newer one, we have, let's put this in. Yeah, we have an exploding derivative. You can see here we have values of 10 to the power of 61, and yeah, it has this behavior. I don't know how to describe this. So
and this is with the joint, right? So
this is a direct differentiation run. So
okay,
basically the directive script. And if we compare the residuals of we have here the residual of the broken, of the newer commit, and here we have the residual of the older commit, and you can see that the relative residual is much, so the convergence of the after this commit is much worse than before. So maybe I don't know.
Yeah, so the exploding derivatives are definitely like related to the residual here.
Okay.
Yeah.
So they're not able to converge to the same level, like with different settings, maybe.
Yeah, I tried to get the version after this, so the newer version, to converge to the same levels by trying some different configurations, but yeah, I was not able to. Maybe it is possible, but not for the same number, not for the same settings as in the older case. And naturally, because we have here, so I tried to do some adjoint runs as well. But since we have not so good convergence of the primal solver, then the adjoint diverges for this case. I think I'm not 100% sure if I remember this correctly, but yeah, nevertheless, the residual is not as good.
I think that the divergence is probably the residual.
Yeah, I think it's just not converged. So
but it's still a big difference for the same settings. Not being able to get closer to similar residuals is quite a difference.
So you posted 2 different commits in the issue you opened. Were you able to nail it down to one commit? Have you done like a binary search through the history and found the one commit where it changes?
No, this was the closest I searched, so to say. So this is one. This was 2 commits of myself and somewhere in between. But I think there was one commit. I can look for it and post it as a comment under this issue if you like to. I think there was one commit where the regression tests of the test framework were changed, and I think somewhere in there the stuff has changed. No.
Yeah, it's between November 19th and December 10th, according to your commits. I'm pretty sure that's, yeah, we pushed a bunch of stuff right before the release then, including all the nonlinear controller stuff. And
yeah, there were, I think, several thousand lines changed. So, yeah.
And you're using JST for this, right?
Yeah, I'm using JST Flux.
And is the CFL adaptation off? All of this kind of stuff is turned off?
It's off. I'm looking at the config. It's off.
Okay. Yeah. Is there anything that stands out?
You don't have any preconditioner specified, right?
I don't think so, but
what's the default for Primal? Is it ILU or SGS?
The default is ILU. Pretty sure.
I think it's ILU. Yeah.
Right. Let's go to the source of truth on this thing.
Yeah.
I'm pretty sure. I'm 100% sure.
You're 100% sure?
I'm 100% sure, yes.
Are you looking at the config CPP?
No.
Can confirm it is ILU.
Pooh.
Okay.
Nice bet.
I give up. I can't. So one thing that changed together with the nonlinear CFL was that default was the value for that fixed factor that we have for central schemes.
Mm-hmm.
So we put that in because in most cases it helps. But it will make the Jacobian. I mean, it helps if in conjunction with that you use a high CFL. If you use a low CFL and that default fixed factor, which the default is 4, I think, the Jacobian is not going to be very accurate. So that might explain why your residuals don't drop.
Yeah, that's worth a try.
So either
going back to the other.
Yeah. So in terms of that fixed factor, you can just put the value to 1. There's an option for that to override the default. Just to try and find the root cause of not being able to converge the problem.
Okay. How's this option called?
Central_Jacobian_fix_factor.
Yeah. Okay. Jacobian. And after Jacobian, can you repeat, please?
Fix_factor.
Okay. Yeah.
It's very descriptive, but it's very long.
That's true. Okay, yeah, I will try that.
Okay.
Yeah, has anything else in JST changed? I don't think we've changed much in JST for quite a while.
No. There have been no changes to. We fixed something for cusp. Yeah, cusp. Add some fixes, but I think that was it. Everything else, it's still the same, or should be the same. Should be mathematically equivalent, apart from some tweaks and moving code around. Yeah, so Tom, you didn't hear in the beginning, but yeah, we had this time domain issue, so to say, and we have the long running one with the differences between 6.01 and 6.2. The one that Toby and Taranya and Hoko are looking into, and there are some questions on CFD Online that people that I think are starting to trip up on this problem.
Yeah, got it.
So that's why I kind of suggested that we talked about these issues.
Sure, but in 6 to 6.2, what would that be?
The guys in Charania, let's say, think that it's the implementation of the new Euler boundary.
Right. Yeah.
Yeah, I have to admit that I didn't.
You're here. Good.
Basically, that.
Hey, Toby.
That fix for that. I have to look into that again. I should have done like for a month, but yeah, that's probably a good thing that it's now on the table again to kick in my ass to get that finished. And to find where the problem is. Yeah. So my current route was it somewhere for the grid velocities in the numerics. So I've always tried to get the changes between the old implementation really written down to the new one. Yeah, but I just have to take another look on that.
Yeah, okay, now I remember. Yeah, we exchanged a couple emails on that, I think.
So does that mean that more people see that problem?
This is TFT online, so there's a chance that people are just setting up their cases wrong all the time.
So that's an inviscid case. These are the issue in the 6 to 6.2 are all inviscid cases, correct? So with viscous walls, it's fine.
I don't know. I don't run any unsteady on a regular basis. I only run unsteady when I break a test case, basically.
Yeah, but I don't think it's related to unsteady. That also happens for steady state cases, right?
But I guess if it's a viscous case with symmetry boundaries, there might still be some difference as well. I don't know.
Yeah, and maybe grid motion is needed here. So I wonder if just a static grid unsteady case shows this behavior. Toby, do you remember by any chance? Did you need to have grid movement?
I'm just checking the issue right now.
Yeah, so am I. You guys did a nice job to actually go through all of the different options.
Pedro, which thread are you referring to on CFD Online where people had that problem?
I can try and point you to them.
Okay, here the pitching Naka 6.4. Okay.
Yeah, there's that, and there's one called unsteady restart divergence.
Okay. Yeah.
Which is this guy that is trying to replicate some results from a paper. Back when Ruben and Heather and so on were doing all that work on FSI. And yeah, well, it's of course the paper doesn't give him the exact data, but it seems that his case just explodes if he restarts from a steady state. And I had to look at it, and it's not a restart bug. It's just something with the physics makes the case diverge.
Yeah, he's also using the Aeroelastic stuff, and actually, I'm not quite sure how well that works.
Yeah, that hasn't been used or updated in a long time.
Yeah, but I mean, all that does is solve a 2 degree of freedom problem and update some coordinates.
Yeah, it's a little ODE problem. It's like a spring system.
Yeah.
Okay. I mean, at first glance, though, I think these are probably two separate problems. We just have a couple different things that are going wonky with unsteady calculations. This one does seem to be boundary conditions and maybe the grid velocity in the new Euler/symmetry boundary condition. I've just been reading through that old issue, which is actually pretty comprehensive. So.
Yeah, but the new boundary condition looks a lot better than the old one.
Yeah, I think it's quite nice. We may just be missing something with addition of the grid velocity terms in the boundary condition.
Okay, so I was gonna propose something for C system matrix.
Yeah, sure. Go ahead.
Let me try and share my screen.
Just to finish that, Toby, if you have a minute to look at that again, or at least
yeah, sure.
Just point me, if you can maybe bump that thread, leave another note, and maybe point to the latest findings. We can actually reactivate that issue a little bit. I mean, don't feel like you have to go off and do it all yourself, but maybe just bump that thread.
I think it's just fair that I have to take care about that as I'm responsible for all that. Yeah, but I will take up again that GitHub issue and rerun the stuff and with the newest version to see if anything else has changed.
Okay, that'd be great. Thanks.
Is my screen showing up?
Of course not.
Nope.
Oh, come on.
I mean, there's again the screen sharing symbol, so the screen symbol, but
Oh my god, I'm gonna throw the computer out of the window.
What did you do last time?
I don't know. I did the same thing. I did the same thing twice and got different results. So anyway, I think it's easy enough to explain. So you know how we have like the blocks, like the blocks of the matrix are supposed to have 2 dimensions, right? We have n variables and n equations, correct? Can you guys picture that?
Yes, the small blocks.
Mm-hmm. Okay. Who can tell me which of those is the rows of the block and which is the columns of the block?
I have to go look. I haven't touched that in years.
Because I'm pretty sure that the code only works because those 2 numbers are always the same, and I'm pretty sure it's gonna break if that thing is ever used differently.
That's not well. I guess they're always square in our cases, but yeah. So do we have them flip somewhere? Is there a bug?
I'm sure there is. I don't know if there is one because I also don't know how it's supposed to be. I don't know which one is supposed to be the rows and which one is supposed to be the columns.
Probably you just have to decide on something.
What?
Probably you just have to decide on something.
Yeah. I was actually gonna
go ahead.
Go on, Tom.
I was just going to pull up the code and look and try to refresh my memory. I haven't touched the linear solver stuff, honestly, in a couple of years.
Yeah. I was going to propose getting rid of, assuming that they're square and that's it. The blocks.
I mean, I think for all practical problems, they're going to be square. I think they have to be, right?
Yeah. I mean, if you want to solve systems, they need to be square because all the preconditioners need that. Yeah.
So what's the implication of changing? I mean, are you just kind of going through finding all the nvar and whatever? I don't know. Are there indices that you're concerned about, or is this a performance thing, or what do you have in mind?
It's just a simplification because going through the code, yeah. So some of it is not going to work. Yeah.
Okay.
Mostly because of me. For example, the matrix products will assume that the blocks are square. So I can either fix those. It's not a big fix because it's only defined in one or two places. But if I'm to fix that, we need to kind of agree on a convention for what should be number of variables and what should be number of equations.
But do you need that for any particular reason? Or?
No, we don't. We don't use it. It's just the code was written generic like that, assuming that they could be different. But at the moment, we don't use it for anything.
Yeah, I mean, even the definition, the way we use the term nvar in the code is essentially the number of equations. I mean, if you have a system of equations, the number of variables is the number of equations. So
yeah.
Okay, you want to get rid of the n equation essentially. Okay.
Well, either getting rid of it or defining a convention and fixing it.
I mean, if there is not any particular reason why we have why we need that distinction between these two.
Is there anything? So apart from solving systems, is there anything in our whole linear algebra library that we do that has non-square blocks?
No.
Nothing. There's no reason we might want.
Not at the moment, I would say, because at the moment we cannot really use it for something else because it's somehow still a little bit tied to the geometry structure and stuff like that, right?
Not really. So the only thing that it's tied to the geometry for communication. That is a hard dependency, but for the sparse structure comes from the geometry, but doesn't have to. We could pass the sparse structure at initialization. So the matrix used to build the sparse structure from the geometry, but I moved that bit out. So now if we wanted, we could break that dependency.
Yeah, I think that we should do that to have like the matrix structure a little bit more general, and then I think it would make sense to still leave the option to have non-square blocks, although we don't use it at the moment, but well, who knows?
Yeah, the communication's going to be tricky.
Yeah, exactly.
Although that might not be impossible to do. I mean, we just need the initialization, so we need to build the lists. For now, it lives in geometry, but we could, if we really want, we could create a copy that lives inside the linear solver just with the initialization. So we could send in some vectors that we need to use for the communication or something like that. I mean, does anybody have any desires to use the linear algebra stuff for anything else? I mean, it could be interesting, but we've never really explored it.
It was used. It was used at some point in the structural solver to keep the mass matrix and compute some time residual, because you need to do some products. But we refactored that to, because it was not being differentiated anyway. It was in the matrix, but it was not being differentiated.
Yeah, I mean, given it's a research code, I think I do kind of like the idea of keeping it general and separate. So I mean, you never know what people are going to come along and do, and maybe they need some kind of weird operation done inside of a solver they're writing or working on or something.
Hey, maybe also from a maintenance perspective and stuff like that, it makes sense to like break the dependency.
Okay, so for example, in the set block and add block and so on, the number of variables is used as the number of rows. It's used as the outer dimension, and the number of equations is used as the inner dimension.
I think this would be easiest if we actually had a non-square problem, so we could try to just pick on the convention and set it and check it.
And yeah, and the matrix itself is not. Yeah, the matrix itself is not constrained to be square. So shall we go with that then? Number of variables is the outer dimension, number of equations is the inner dimension.
I don't have any preference, so.
Yeah, well, I mean, maybe take a look at how the loops run and see if there's a performance advantage one way or another. I don't know. In the case you are doing, well, I guess it depends which direction it's not square, but. Yeah, maybe it doesn't matter.
It would depend on the relative dimensions, right?
Yeah, one way would be better than the other, but you'll never know that. Yeah, then I would say pick a convention and just make sure there are some comments, and I think that's the best we can do for now until we can actually test it.
Okay.
So I'm just looking at the matrix vector product. So the only reason why the geometry and config is passed there is because of the communication, right?
Yeah.
Okay.
Yeah. Yeah, and the reason, so that was I wasn't 100% happy with that decision to put the communication stuff in the geometry. The reason I did it is because the geometry defines all the halos. So it is somewhat convenient to have it there. We could move it out with some effort, but like it could be its own, like the communication structure could be its own class, and we could pass that in, which is, well, that's another dependency, but it could be done. It's simpler than passing in the entire geometry.
But it does not need the geometry, right? The communication itself.
Well, by the time it gets there, it already has all the vectors it needs for communication pre-processed. They just live inside of geometry. So essentially, it just calls the non-blocking routines to communicate with pre-existing vectors. So we could potentially pass in, we'd have to pass in some information. So like the vectors and maybe we'd have to set up some requests and some other things inside, but it could be done.
Yeah, but that also means we have to do the geometry preprocessing before we actually can use it then.
Yeah, of course.
Yeah,
okay.
I mean,
because
at
it's
some
still
point,
always linked to the partitioning, right?
yes, yeah. The right-hand side vector is going to be chopped up somehow.
But Tim, you want to break the dependency just for testing, or?
Well, I don't like that the geometry and config is passed to that matrix vector product there.
Yeah. No, I mean,
but I see that it is coupled. I mean, the communication is of course coupled to the geometry, because this is where all the partitioning happens.
But if it's just for communication, we can make it not communicate if the geometry is a null pointer.
So you mean you can use it without the parallel structure?
Without the MPI?
Yeah.
I don't know. I don't know what makes.
Yeah, so this is the reason, right? So I'm thinking when we want to use this matrix vector structure, maybe just independent of the partitioning for some other stuff.
Yeah, I mean, I have a suggestion.
We cannot do it because we always assume that they are partitioned with like the mesh is, right?
Yeah, that's right.
So I have a suggestion. If you are really serious about trying to break it up, we should look at what PETSI does to let the users define their communication structure, because it's basically the same idea. I mean, they've created a completely standalone, set of solvers and preconditioners that also work in parallel. So they must have a way of registering how the problems are partitioned. We could take a look at what they do. I mean, they've been doing this for a long time, so I'm sure they're doing it in a clean way.
Yeah.
In principle, we only need to know the global index of the ALO points, and that's all you need to communicate.
Yeah, I mean, so we could pre-process all the MPI stuff before setting up the system, which we do anyway, but then just find the minimal set of data we need to pass in. So maybe it's just a vector of global indices with their rank that they communicate with or something, and just use that to set up communications inside.
Yeah, also having that in a separate structure, like you already suggested.
But these buffers that are used for the non-blocking communications, they are reused for whatever communication we do, right?
Yeah, at the moment, yeah.
First, you need to set the count per point.
Yeah, we use so the MPI is a little bit funny. It turns out that if you use persistent memory, at least the first time through the calculation, you'll see that it speeds up. It actually speeds up if you reuse the same memory location every time. So I think internally what MPI does is it sets up some internal buffers. And if they're related to the same memory location that you're using in the application buffers, it turns out it's actually faster to use these persistent things. So what I do is just set up one set of arrays that are long enough to handle any of the communications that we have in the problem, and then just reuse that over and over again, because they never happen concurrently. I mean, all of our communications at the moment are sort of one by one with some work in between.
Okay. And so I'm looking at the code and trying to. So you allocate enough space for any communication, but then for each communication, the data is stored contiguously, let's say.
Yes. So
you
starting from
could
0
store,
up to whatever.
Okay, and the next. So what I mean is the start of the information for the next point starts where the information for the previous point ends. Do you see what I mean? So you have count per point information that you need to send.
Yes, right? We always send it in packets so that that's the most efficient way to do it, because you're going to unload it by point, and so you want to have them all together. I think it makes the packing and unpacking easier. So yeah, I call it a packet, I guess, in the code, I think.
Okay. Yeah, I mean, so from what I'm looking at, it's just a matter of getting the arrays from geometry and passing them to the matrix, and the matrix keeps those arrays or pointers to those arrays instead of the geometry.
Yeah, if we want to reuse them, we could just send in pointers.
Because the matrix then just looks directly, gets access directly to those arrays. It doesn't really call any method of geometry, I think.
Yeah, I mean, maybe we can really create some intermediate structure there.
Well, it calls post P2P send.
Yeah, the geometry kind of owns the communication checking, so the launching and the checking for completion. So there's some code there that we could move over, or yeah. I mean, it's not impossible to untangle. It's just
the question is just how to define that parallel layout, right? That you have. How to somehow pass that to a separate class.
Well, you just put it in a struct or whatever, and you pass that.
Yeah, but what I mean is how to create then some custom parallel distribution, right?
You mean for a custom application of the matrix that is now linked to?
Yeah, exactly.
I mean, that's the job of whoever needs that, right?
Yeah, I mean, there should be at least the case that there's no parallel partitioning at all for these vectors, right?
You want to cover the case where there's no communication?
I guess it makes sense, yeah.
I mean, that's possible as well. But that we can do. That we can even do now. We just take make geometry optional, and if the geometry is null, we skip the communication part.
Yeah, okay. I mean, of course you can do it, but I mean, I don't like that solution.
Well, you're making this very difficult, Tim. I don't know.
Yeah, I know. Sorry.
I think the person who wants it so badly should be the one to start working on it. That's what it sounds like.
Exactly. All I wanted to know is which dimension should be number of equations and which dimension should be number of variables. I think I feel I'm getting too much.
30 minutes later, we're digging up.
Sorry. Okay. No. Let's start with that.
30 minutes later, we refactor, new pull request, refactor SU2.
Sorry, I just always see the things that one could do, but no, just start with the dimensions there. I think it's okay for the moment.
Yeah.
I think it would be good to have a typical use case, some kind of use case where we can envision doing this to just help design what we want to do. If that comes up, then I think we can start working on it. But I think there are a million other things we should work on, and until somebody needs it, I think this can wait.
Yeah. Oh yeah, it's definitely not urgent.
Yeah, it's true. Okay. Yeah, but I think you can go ahead with your change. No objection.
Yeah.
Apart from what I just said.
Okay.
Cool.
Are there any other topics out there from people on the call?
I don't know. Maybe someone has a question or a note.
I can bring something up if not. So I think, Pedro, you and I were going back and forth a little bit about file layout. So I figured we'd just talk about it for a minute. So is everybody happy with the current layout? What do people think about going one step further and sort of flattening? So basically taking out the modules and the extra level there and moving CPPs and HPPs to the same place.
I would be in favor of. I mean, I like the layout that we currently have, but like you said, we can get rid of some levels there. And I'm also in favor of combining includes and the CPP files. Although, like Pedro already mentioned, of course, a proper setup IDE should take care of that. But it's always also, I don't know, complicated to just, well, it's not complicated, but it's a little bit annoying when you create new files and then you have to, or a new class, and you have to split it up in separate directories. I don't know.
Yeah, I don't think there's a good reason anymore for doing that. I mean, I know IDEs can help you navigate, but I don't think there's like a best practice for why to do that way. I think having the source and include directories is maybe a little older, like old school. I don't even think we need those.
Especially because it all gets compiled in the same thing. It's not like we have private headers and public headers for client code. So
yeah, exactly.
But I would have, in terms of navigating the code, the thing that makes it harder for me is that once you open, for example, if you open solver and variables, that takes up all my tree view of the code.
Yeah.
So I would have some subdirectories in those just to group things that make sense to be together, like flow solvers with other flow solvers and flow variables with other flow variables, just so that you can kind of skip. If you're working just on a particular solver, you can more quickly switch between the variable and the solver and the output for that thing, and I don't know. So I would trade the top level with some lower levels.
Yeah.
I'm not against that. Yeah, I'm okay with that. See no problem. Yeah, what bothers me right now is navigate. So if you jump between, I'll use common and SU2 CFD as the example. And then inside of those, you have their includes and their source. So I mean, you might be working on the flow solver and then have to jump all the way back up to find config or something down in the geometry structure. It's like going up 4 levels and then back down 4 levels, which just seems kind of ridiculous.
So you want to get rid of the separation between common and SU2 CFD, for example?
Yeah, I think if we have folders that are geometry already, I mean, I don't see a huge benefit to having common separated from all that. For me, it doesn't add much value. I don't think. The reason, I mean, a long time ago, it was that, and I guess we still do to some extent, you can build that library separately and then it gets linked into all the different executables. But, practically, I don't know how much value that separation in terms of folders gives us anymore. I mean, I think it's just confusing.
Right now, the way we build it is common is built into a library, but then CFD, we use some objects, some object files for other for dot and def and those, right?
Yeah. I mean, we need a solution. Yeah, go ahead, Tim.
I mean, we also have now SU2 CFD as a library. So in theory, we don't need an extraction anymore. Of course, it saves some space, but I don't think that it is that much, actually.
So, I mean, what I was advocating for a little bit in the post was how we do the top level, I think is still up for debate. So whether you have like solvers as a directory directly up in SU2, I don't know. We can talk about that, or if you want another folder to hold all of these geometry solvers, whatever. But I think then at that point, each of those directories just becomes a library, because they're all, if we build all the geometry classes together, that makes sense to me to put into a library. If we build all the solvers, that makes sense to put into a library. And then from there, we just link what we need up into the different executables.
Yeah, I think that would make sense, yeah.
And we probably throw away automake when we do that?
I would suggest so, yes.
You sound excited about it, Pedro.
I mean, I don't mind it that much.
So it sounded like you were excited.
I think you have to do that. Otherwise, for automake is not building all the libraries in parallel. So that would be really a bottleneck.
It waits to link each library before it moves on to the next.
Yeah. So with automake, it's not possible. Well, it is possible, but if you have a lot of cores,
I still use it. I'm on some old machine that Rafa has. I still use that thing. So I'm not against it.
If people feel strongly like for keeping automake, then of course we can also keep it. But I think it is complicated to maintain two build systems.
Exactly. That's why I said it. It's just because if we're going to break it up in more libraries and we need to do it for two systems, it's a bit meh.
I mean, I do see that there are also some problems with Meson because of Python. But yeah, I mean, so far I think.
I have to edit the Meson.build, and every time I want to add my 11 herbs and spices to the compilation.
What do you mean?
Well, I usually compile with more flags than we have by default.
Okay.
So I usually edit the file.
Can you make custom? Can you make custom build configurations in Meson that just include it, and we can just put that in the repo? I don't know. I haven't tried to do anything like that yet.
Does it work exactly like Python? Can we do, for example, import user config? And
I'm guessing you probably have to define this in a file somewhere, some kind of. Yeah, I don't know. I don't know how Meson does it.
You mean separate build flags, and you want to have like separate options? Or presets?
So for example, we initialize the SU2 CPP flags as an empty list, right?
Mm-hmm.
So I don't know if there was a simple way to just do import something and if we are able to import that file, then we initialize that list with whatever the user has in that list, instead of just empty.
Yeah, I don't know whether something like that exists. I mean, you can always use CXX flags. I mean, that's still possible, of course.
Yeah. Okay.
Problem is also that the flags like differ between compilers. It's also another problem.
Yeah, exactly. You can't be too specific, otherwise you need to have cases for different compilers.
Yeah. This is why Meson has some predefined things. For example, the C++11 flags and stuff like that. This is predefined, so it will expand to the correct command for the different compilers.
Mm-hmm.
But for other stuff, I don't know. Especially warning flags are also complicated because they sometimes also
yeah.
differ. Of course, you can have like different presets for different compilers. Like you can have, I think you can have it with CMake and stuff like that. I think there it is possible to have something like that. Yeah, I don't know. We can have a look whether that's possible. But are they usually that different, the flags that you use?
No, it's just the architecture flags and things like that.
Yeah, I mean, Pedro, it's not as glamorous, but what I do sometimes is just keep in my bash RC some, like Tim was saying, some CXX flags, and then they just get passed in. And so if you can do that, I mean, it's kind of an ugly workaround, but it works.
That could work. I mean, for on my machine, I just use an IDE, so that doesn't matter.
Right.
But on university cluster, I don't think I have a bash RC file. Maybe I have something with another name, but.
Yeah. But I think it makes sense then to get rid of automake as soon as possible, actually. But
yeah, I mean, the two problems here are we keep moving files, which I think is probably infuriating a lot of the developers who are, they're working on things and then everything moves.
Oh, we don't know because they don't speak.
But well, that's potential issue one. Potential issue two is if there are any people out in the wild that are depending on automake on old clusters, that could be an issue. So it's not great, but I mean, it is true that a lot of clusters out there are like 5 to 10 years behind in terms of compiler and dependency technology. So I mean, while Python 3 should be pretty much standard, you'd be surprised.
yeah, I know. I mean, but we still have the case that sometimes automake is not even working because it's not kept up to date. So I don't know whether it even works with 704 at the moment.
That's true. I haven't used it now in months. So
what automake?
Yeah, automake.
It's working. I've been maintaining it. Yeah, it works.
Yeah, I know that there are 1 or 2 issues you fixed in an issue. Maybe a month? I think you and Aaron were going back and forth about something.
And Giant has been putting fixes on it as well from time to time. So it's up to date at the moment.
Yeah, Giant, you're on the call, right? Are you using automake?
Yeah, sometimes I need to use it for the clusters here because they don't have the like you said, some clusters are old, so Meson doesn't really work on some of them.
Yeah, that's my concern.
But you can pretty much always install Python 3 as a user using something like spec or something like that. I mean, it's almost always the case, I would say.
Or Anaconda, you can just have Anaconda, right?
Yeah, that's also possible.
Yeah, I mean, it can be just a local install, right, to get Mason going.
Yeah, I say that, but I like they recently updated the ability to do that in the cluster. Now I haven't used Automake in a while, so
Okay.
Maybe if we have like a proper, have it written in the documentation somewhere how to set up Conda, or very quick reference to something like that. Maybe that would help transitioning.
Yeah, I mean, also they're just on Mac, for instance, you just need a couple lines to get the homebrew Python and it works perfectly. It's great. So yeah, we could add a little blurb to help people. I think there you already put something there though, Tim, I think, right?
Yeah, but not how to install Python.
Oh, and before I forget, if we move files again, we should probably get rid of the all the //// we have, and just set up the include directories properly for each of the libraries we build.
Yes. Yeah.
I think, yeah. Plus, we'll get rid of some // in this case, which would be good. Anyway, even if, yeah. Well, but yes, I agree. Make it so there should be a root, and then, from there, go down for each library.
I don't know, because at least with Meson will include the top the top level, right, Tim?
Yeah, exactly.
So it's even more than just the root. But by default, Meson will give you the parent directory of a given file.
This is why we sometimes have no problems with compiling Meson, but compiling with Automake or something like that gives problems.
Yeah, or for IDEs that don't
yeah, exactly.
Yeah, I've had that problem in Xcode. But so you're saying in Mason, so if let's say you're in the solvers folder and we put a mason.build there to build all the solvers into a library, you're saying that even still, you would have to start all the way up at SU2 when you're doing includes in those files?
No. I would say that in the project, we should configure the include directory to have solvers in it, so that we don't have to do any backtracking up to the root and then come back down.
But that should be quite easy with Meson, right? If you have like shared libraries or static libraries in that case, I guess, when you define them, then you also define the include directory for them.
Exactly.
Yeah. So each of those can just be a package. Yep. Yeah, I think it's a cleaner way to go.
Right. So I guess we should write this down on that file restructuring issue, and including the decision
to proceed then. I mean, what would be the best strategy of doing that? Because I think that we have to do something like that all at once, and we cannot do it really in single steps.
All right. Well, I think first we need to finish moving the files. We definitely need a FEM folder.
True.
And there are not a lot of them in CFD. There's basically just the fluid model and the iteration that are left to restructure there. And common has a lot of inlines that need to be moved to the HPPs. And it has a lot of FEM files that I guess can just be moved to their own folder.
Yeah, it shouldn't be that much work that is left, I think.
I don't think so. I was going to say, why don't we just divide and conquer? So, I mean, I'm happy to do, I've worked on both those. I'm happy to do the fluid models, for instance, and just break them up and submit a pull request. Plus, I don't think people are working on that too actively. Well, I'll take that back. I think the Nemo folks are doing quite a bit there, but anyway.
But they are already divided in CPP and not HPP files. So. Okay.
I think it'll be manageable though for them. I think it's okay.
Yeah, iteration structure should be also very easy, unless we also combine that with the refactoring. But maybe
I would do one at a time.
Yeah, because it definitely needs a refactoring.
Well, I mean, it's mostly just deleting methods that are. It has a lot of empty methods defined for
the base class.
Yeah, a long time ago, Ruben and I think had when he was visiting Stanford, we thought, putting in the FSI stuff that we would need a lot more routines than we did in the end. So the iteration classes originally we thought would do a lot more, and they're actually quite simple in the end. So we didn't need all that extra stuff. So yeah, mercilessly cut stuff out. It's we don't need it.
Okay, I will separate the iteration structure.
Okay, I'll do fluid model. I can even talk to the Nemo folks and let them know what's going on.
Okay, Pedro, the rest is for you.
I'll do the whole common.
Well, yeah, what else? So in common, let me see. What else is there though in common, just to be specific? Because already some of it's done.
Yeah, some of them should be also very easy, like MPI structure and option structure should be.
Oh, I just
I can use some of the.
I just opened grid adaptation structure.inline and it's an empty file. Nice. This one will be easy.
We can remove by that chance we can remove the grid adaptation code altogether.
Yeah, we probably should.
Yeah, I can work on the grid movement and grid. There's I think grid movement. I can remove the grid adaptation structure and take.
Okay, so you deal with grid movement and the grid adaptation.
Yeah, maybe talk with Brian before removing the adaptation structure.
Yeah. I'll communicate with Brian on that.
Okay. Cool. So I guess I can move some of the FEM structure things to their own folder. Yeah.
In your branch, Pedro, or did you already change the AD things? So did you move them to a separate to like?
Not the AD. I just simplified the data types. So the data type structure. That's all one. That's just one HPP now. But I can do the AD structure too if you want as well. Moving the index.
Well, if you're working on that, or if you have that branch open anyway, then maybe it makes sense. I don't know.
Okay, I can do the AD structure too. And
that's almost everything that we have. MPI structure is very simple. I mean, it's very simple actually. Option structure as well.
Option structure, we should probably leave it separate like that.
Yeah, but we can move it to a folder. This is what I mean.
Yes, yeah. Yeah, maybe we could have an options and configuration folder.
Yeah, maybe it makes sense to combine both into one folder.
Especially when we eventually get to refactoring the config, it will probably not be just one file. So I guess it makes sense to have a directory for that.
Okay, perfect.
Another thorny topic, but it's good to probably do both at the same time. Do we want to reformat those files when we move them, or no?
I mean, moving is very simple, right? And JIT tracks that. So I don't expect a lot of conflicts by just moving the files.
Okay, so we'll just move them.
While we've been restructuring, we have been reformatting.
Yeah, but I mean, Tom is talking about the CLang format stuff.
Oh,
Yeah, we can automatically reformat, but maybe that's too much. Maybe we should do that piecemeal separately.
I would suggest that, yeah, because otherwise we have a lot of conflicts.
Yeah, if it's just moving the files, it's easier to merge than I imagine.
Yeah, I think that should work quite well, actually. I think Jit is really capable of doing that.
The thing is that when we split the files,
yeah, then not anymore. You're right.
only one of those is actually moved. The other ones are considered new and deleted.
Yeah, you're right. I always forget that.
Yeah, it just takes the one that you have the most code in and says that was the one that was moved.
Well, in that case, we can also apply sealing. I don't know. Maybe it would be too much, though.
Can we? I mean, if it's automated Clang formatting, wouldn't it? Can we just do it at the end in one commit and in one PR for the entire code base?
And we don't.
I mean, we can. The question is how bad. Yeah, question is how bad that is. I mean, I've always liked the idea of submitting a pull request where or even just formatting the whole project, and then since everybody has the .clang format file, I'm wondering how bad it would be if everybody then in their branches runs it and does do a diff against the formatted version of the project just to see how bad it is. I don't know.
We need volunteers. We need the people that are less up to date with develop to test that, I guess.
Because it might actually work. I mean, it might avoid all those white space conflicts. I mean,
but that holds a lot of people back from merging. I mean, already the splitting of the files, I think that holds back a lot of people and updating their branches. Not because it's complicated, but it's just an additional step.
I don't know. Is there a way to make a poll on GitHub or something?
I'm also not a big fan of asking a lot of people what their opinion. The democratic way.
Oh wow! Yeah.
What?
I mean,
Sorry?
we could. Yeah.
Dictator Tim.
You want to be like the Python guy, the benevolent dictator.
I can't have that in real life, so I have to do.
That was his official title, I think.
Yeah, I don't know what the best way would be. We can try it with having like all of that at once.
I mean, does anybody have a pull request with a lot of changes right now, or just a branch rather, not even a pull request? Pedro, you've got a couple.
I don't have any branches that are out of date with develop.
Okay.
But I have reasonable size pull requests.
Yeah, what I could do is go, I'm sure I probably just have some stale old branches that are way out of date that I'm not even going to use. I'm sure other people do too. What we could do is just
I have those. So. I just don't care about them.
Yeah, enough. So but those are perfect. So we could go, if it's a little bit out of date, just use it as a dummy. So you could create a branch off of develop, run the formatter, and then take one of your stale branches and run the formatter and see how it looks.
But they are all from before the file splitting. So I think the diffs will be there just from the splitting of the files and not the.
Yeah, you're probably right.
Maybe it's not as bad as we think, actually, because I mean, if you just apply it on your branch and then you merge, I don't know.
I can try it on the one I have with the hybrid parallel boundary conditions.
Yeah, I mean, maybe that would be sufficient, even if it's not out of date with develop. Is just trying to do them separately. So format develop and then format your branch and see if the diff still looks the same.
Yeah, this has a lot of green and red interlaced. So I guess in terms of a worst case, this is probably up there. The current diff has a lot of, delete one, introduce a new one kind of thing.
Yeah.
Okay. Yeah. Maybe do that test and then we see how bad it really is.
Okay. And before we move all these files that we agreed on, the iteration, the thing, and the FEM, let's merge some pull requests, huh?
Maybe. No, we can do that. Yes.
Yeah. We can.
We should do that.
Although the list is not that bad, actually. I mean, half of them are work in progress, so it's okay. I mean, we're doing okay, but we got to keep moving. I was going to say another thing related to the formatting. I was running CPP lint the other day, and we still have tons of tabs in the code in different places and tons of white space issues. So just another vote in favor of getting the formatting under control.
Is sealing format also taking care of that?
Yes, it will strip all white spaces and tabs.
Okay.
Yeah, it'll take care of everything. So it's.
I played around with the settings of the format. I was playing around with that the other day. I don't know. If we want to have, so in function declarations where we have one argument per line, you guys see what I mean?
Yep.
You put this one. If we want to keep that, we need some extra options in that file, in the CLang format. Otherwise, it will pack. I think the current setting, it will pack the arguments.
Yeah, it'll put them across whatever 120 lines. So I'm open. I mean, if folks prefer that, I think that's fine. We can customize those options a bit. That totally open.
But I don't see why we should keep it in a single argument. But I don't know.
It just seems to be the prevailing convention in a lot of files.
Oh, I think that's just because it kind of looks nice. So I think in this opportunity, I would say if we're going to go for Google format, we should just go more or less exactly the Google format as much as possible. So I mean, we do advertise we're doing it, but I don't think we haven't really abided by that.
And by default, it's just putting as much arguments in one line as it can.
Yeah, it will break them up.
It
will line them up by the parentheses, but
yeah, okay.
It won't reorder them for you, so that's still on the programmer. So it should be that your inputs should go first, so all the const inputs, and then any like input output parameters should go at the end. So it won't reorder that for you.
But it's not splitting the type from the name, so it's from a variable name.
No,
so
I don't.
They are always on the same line, right? Yeah, I guess so. Otherwise, it would be.
Yeah. No,
I think so. Yeah.
Has anyone else in the call played around with this format?
I think I just applied it once, and that's it. And looked how it behaved. But...
Okay, it's just that for things like the iteration, it kind of makes sense because it has a lot of arguments.
Yeah, and I did something of that sort with Solver, but I did that manually, and it was a pain. But I think it looks a lot better when they're just listed down one line at a time.
Yeah, part of the issue there is we shouldn't have so many arguments. That was bad. That was bad programming a long time ago, so we should clean it up. But, well, one thing at a time. We have lots of things.
Yeah, but should we split the files or continue splitting the files without C-length format then? I mean, I don't know what the best order would be then.
Well, I think Pedro's test is maybe going to eliminate how bad it'll be. So if everybody can just run the formatter locally and the merges, that part of it, all the white space stuff is okay, then maybe it's not such a big deal.
Then you would prefer having like one pull request that changes everything.
Potentially, yeah. Just get it all done. If it's not, a disaster. And then once we do that, I would be in favor of automating it. So either as a pre-commit hook or as a GitHub action, like we talked about.
Yeah. I'm not a big fan of having automated commits. This is why I don't like the action approach.
When are the actions applied? Before you merge, or
depends on how you want to do it. We could just say, okay, whenever it is merged into develop, we apply it. We can say, okay, whenever you push something to a pull request, it is applied. Depends.
It could be interesting to do it by pull request, because over time, I mean, those are the files that people are changing. So as long as it's applied to whatever is being changed, over time, it should stay formatted.
You mean in the pull request? So once you push to a pull request, it should be applied?
Well, either as the pull request is staged to go into develop, or as it goes into develop. I don't know if it matters much. If it's automatic.
We can have it as part of the cross compilation, for example, at that stage, which happens whenever there's a merge or a push to the develop.
Yeah, that could be interesting.
Okay. Yeah, but we can decide that after.
I mean, what if we did that basically now? I mean, then nobody has to. Well, I guess once they pull develop, yeah, okay. I mean, if we did it for master, it'd be fine because nobody would merge in master. But I think it'd be better for everybody to have it as they're working. So,
well, we would merge into master develop eventually.
Yeah,
that would be a good test as well.
That's right. Yeah, you could just see how bad that looks. Okay, so we're running way over time, guys. I probably have to jump off here in a minute, but yeah. So just to come back to what we just said, a lot of things about this last topic. So what's the conclusion?
Yeah, so we do the file
headers and courses together.
Yeah.
No division between common and CFD.
Mm-hmm.
Maybe some subdirectories in the folders that have a lot of files to group things by physics, turbulence, flow, and so on.
Mm-hmm.
And set up the include paths in the build system so that we don't have a lot of backtracking up to root folders and then coming back down.
Yep. And then auto make is maybe on the chopping block. I don't know. We need to discuss that or put that in the post. So I'm noting these down because we can just put this.
Maybe that would be good timing then. To get rid of auto make.
Okay. So remove automake if people are okay with it. And then we have all this client format stuff. So
should we include that together in the same discussion or make a new one?
Yeah, well, the only reason they're slightly coupled in my mind is if it's going to be really nasty, then it would be good to do it when we break up the files if there are more than one.
Yeah.
If there are more classes per file, we might just do it then anyway for some of the files. But if it works well, then we could do it independently.
Okay. Then first we wait for the feedback of Pedro before we continuing restructuring or splitting the files.
No, that feedback is just for the auto formatting, right? We'll still need to finish the splitting. So you're gonna do the iteration.
Yes, splitting done. Yeah.
So yeah, who's doing what? So I'll take fluid model. Tim, what did you say you're going to take?
Iteration structure.
Iteration structure.
And
Giant is doing grid adaptation and grid movement, right?
Yeah. Yeah.
Okay.
And I'll do a few more of AD structure, and I'll move some of the FAM files to specific folders.
Okay.
I can also do ADT structure, since I think that's like the only one that's left after all of that.
Do what?
ADT structure?
Yeah, do what on it?
Oh, is it just one file? I just assumed it had multiple class definitions in it.
Yeah, it has multiple classes, yeah.
Okay.
Oh yeah, it does have different children. Yeah.
I meant splitting it, yeah.
Yeah, then I will do the rest.
Yeah, I removed the inline for that a couple of weeks ago, but I didn't split it.
Okay. I think then we have everything, right?
Yeah.
Yeah.
But let's try and merge as many pull requests as we can before that. Are you splitting the grid movement as well, Giant?
Yeah.
I don't know. Is it worth splitting since we have all this talk about?
Oh yeah. Well, yeah. I guess I could.
Actually.
Yeah, because we were planning on extracting all the FFD stuff from there.
Maybe just move the inlines and.
Yeah.
Yeah, maybe just move it to a separate folder.
Yeah.
Maybe we don't have to deal with that actually. Yeah.
Yeah, I'll see. I'll do the others and then come to grid movement and figure it out.
Okay.
Yep, sounds good.
All right.
That's it.
So let's have some pull requests then.
You cannot stress that enough. No, it's good. We have to do that.
Yep. Okay, guys. Shall we call it here then?
Perfect.
Yeah.
All right. Well, then we'll see you on GitHub.
Yep.
Yep.
See you guys around.
Okay.
Okay. Later, guys.
Bye-bye.
Bye.